Good morning, dear students. So let's start our class now. So the agenda for today is first, I will complete the remaining portion of arithmetic progression. Once this discussion is done, then I will discuss with the questions of the two DPPs I had given yesterday. If you have any doubt on any of these DPP questions, if it is not, or once we resolve these questions, then I'll give some representative questions of arithmetic progression. So we'll make practice before we proceed for the next topic in sequence and series, that is called geometric progression.
Okay.
So I hope all of you are able to hear my voice clearly and all of you are able to view the digital screen, correct?
Yes.
Okay, great. So if you recall that where we actually concluded our class yesterday is that how to determine a certain number belongs to a given arithmetic progression. If you recall that we did so, and I just want to you know put this thing in front of you so that you can have a look into it and just recall. Yeah, we had discussed this thing, leveraging the concept of you know contradiction. I hope all of you are able to view the note what I placed now, correct?
Yes.
So just quickly discussing because that thing we have discussed, we had already discussed yesterday. If it is to determine whether a certain number belongs to a given AP or not, okay, we should follow the steps as mentioned below. Step one is that we will assume, yes, if possible, let there is a number p, be the mth term of the given AP. Okay, and from there we find that value that a plus m minus 1 into d should be equal to p, and we will find the value of m. Means we will solve that from m. Correct? Huh? Step one and step two, dear students, all of you are able to recall, I hope, right?
Yes.
Step 1 and step 2. And then, if you find the value of m as obtained in step 2 is not a natural number, then you can conclude no. That particular number p cannot be a term in that given arithmetic progression. Otherwise, if it is a natural number, then definitely we can say yes, it can be a term in the it is a term in the given arithmetic progression. Correct, now, dear students. So now let's proceed for the next point because we concluded our last class in this point. Now the next one is that if let me put the a note first, then we will discuss. Now the next point is that if it is to be determined whether three distinct terms, okay, suppose pth term, qth term and rs term are belong to an AP, first of all we need to find a relationship among p, q and r. Then if we see this relation is true for three distinct natural numbers p, q and r, then we conclude these three distinct terms belongs to an AP, otherwise it is not. Let me explain you what is meant by that. Sometime you will get questions, dear students, in future we will discuss that the question, this question will be little advanced, that whether three distinct terms, suppose PS term, QS term and RS term belongs to an AP or not. Okay, got it or not? Okay, so PS term will be given, it is not P, it is a PS term. Suppose it is given that, okay, fifth term, 11th term and 27th term of an AP is given. Okay, then we need to then you need to prove whether it is possible or not, whether these three terms are belongs to an AP, these three numbers belong to an AP or not. Are you getting my point? So question here is that you will be given three numbers and it will be asked that whether three numbers belongs to an AP or not. Suppose three numbers, N1, N2, N3. Three numbers has been given to you and you have been asked determine whether these three numbers belongs to an AP or not. So what we will do? We will do one thing. So we'll assume, okay, let's take this for the, without loss of any generality. Let's assume, yes, these three numbers belongs to an AP. And not only that, the first number is the first number, what is given is the PS term, correct? Second number, which is given as a QS term, and the third number is given as a RS term. Correct or not, dear students? We assume this thing. So then you will get a relationship. No? Suppose these three numbers are N1, N2, N3, then what will get? N1 is equal to A plus N1 minus 1 into, A plus N1 is the PS term, no? A plus minus 1 into D, correct or not? Then N2 is equal to A plus Q minus 1 into D, correct or not, dear students? And N3 is equal to A plus R minus 1 into D. Okay. Now, by leveraging these three linear equations, dear students, okay, always remember that is a very generic statement in mathematics I'm going to make. When you have a number of unknowns, it is important to have that many equations, linear equations, or, to find the value of those unknowns. Correct? No?
Yes.
In general, I'm speaking, there are some corner cases. That corner cases is not in the part of this discussion. Okay. Think about if there are two unknowns x and y, and we need to find the value of x and y, we need two equations. Correct or not, dear students? Now, if these two equations are such that one represents the other, okay, then it is not possible. There are infinite number of solutions. So that is, or no solutions if two are, one is multiple of the others. Okay, so that is these are the very corner cases. But in generic statement, what I can say is that as there are three unknowns here, PS term, QS term, RS term, PQR are unknowns, no, dear students. So I have three equations as you see in the red box I have written. From there, what we need to do? First of all, we need to establish a relationship among PQ and R. Correct, dear students? That find a relationship among PQ and R. Then, if we see this relation is true for three distinct natural numbers PQR, it is not that for P equal to 5 and Q equal to 5 and R equal to 7, you are going to get this relation. Then it is not possible. Got it? No? So P, Q, and R has to be distinct. Then we can say, yeah, it is correct. These three distinct terms, okay, belongs to an AP. Correct? No? Got it or not?
Yes.
So this is the thing. This is one point what I wanted to discuss with you. Now, there are some important, observations, and those observations I would like to discuss with you now. Okay, and here it is. I'm just going to place in front of you, dear students. So what it is mentioning is that if A1, A2, A3, all these numbers are in AP, if this is given, okay, A1, A2, A3, up to AN, all these numbers are in AP, this is given. Then A1 plus minus K, A2 plus minus K, A3 plus minus K are also in AP. Obviously, that you understand the common difference will remain same without deep diving into it. Huh?
Yes.
And if you multiply it by a constant term to each term of that AP, that resultant term should also be an AP. Got it? No, this one.
Yes.
And if you divide it by a non-zero number, okay, K, then A1 by K, A2 by K, A3 by K, that should also be an AP. Correct? No?
Yes.
So AM am plus n, am plus 2n, that are also in AP. That means you take the first term as the m, okay? The first term you take as the ms term, correct? Huh?
Mm.
Then you start adding n, okay?
Yeah. Yes.
Then this should also be in AP.
Yeah.
Correct?
Yes.
But A1 power P, A2 power P, A3 power P are not in AP, where P belongs to any real number except 0 and 1. Are you getting my point, dear students? Especially the last point. Clear, no, dear students?
Yes.
A1 power P, A2 power P, A3 power P are not in AP when P doesn't belong. P belongs to the set of real numbers except the numbers 0 and 1. Correct? For example, let's take an, let me give you a very, quick and, very easy example, is that we know that 1, 2, 3, dot, dot, dot are in AP. Correct, no?
Yeah.
But we see 1 square, 2 square, 3 square
Yeah. They're not.
are not in AP. Correct, no?
Yes.
So what we see, A1 power P, A1 is what here? 1, A2 is 2, A3 is 3, like that. But if you make it 0, means that P is 0, then what will happen? Everything will be, all the terms will be 1, na? A1 power 0 is 1, A2 power 0 is 1, A3 power 0 is 1. Because anything power 0 is 1, na, dear student?
Yeah. Yes.
Correct?
Yes.
So then we get, obviously it is in AP. And if it is 1, then what will get? A1, A2, A3, they are in AP because it is already given. So that is why, except the value 0 and 1 for any real number P, we get A1 power P, A2 power P, A3 power P, they are not in AP. Clear, na, dear students?
Yes.
Okay. So these are the points, you should remember. And the next point is also, the next few points are very important. So these are advanced point, by the way. Okay. And these are the points you will see in future while solving the numerical, problems. All these things actually will come to, help us to solve problem in a relatively less time. Otherwise, you need to reinvent the wheel. Correct, no?
Yeah.
If you look into the next point, dear students, what it says is that, sorry, the sum of the terms of an AP equidistance from the beginning and the end is constant and equal to the sum of the first term and the last term. So in simple way, what it is telling is that if the number A1, A2, A3 up to AN are in AP, okay, what it says that, let me write very explicitly. Let me use a different color pen. Suppose you have A1, A2, A3, A4, okay. Then what we get here is that AN minus 3, AN minus 2, correct, na, dear students?
Yeah.
AN minus 1, and finally AN.
Yeah.
What it is telling is that it is the sum of the terms of an AP equidistance from the beginning and end is constant and equal to the sum of the first term and the last term. What it says? You add A1 and AN. Correct, na, dear students? You add A1 and AN. Whatever you will get, that should be equal to, A2 and AN minus 1. Correct, na, dear students?
Yes. Yes. Yes.
Correct?
Mm.
And that is equal to A3 to AN minus 2. That is equal to A3 to a n minus 2. I'm just using the same color so that you can refer it in future as well. That is equal to a4 to a n minus 3. Correct, not dear students?
Yeah. Yes.
So now let us revisit the statement, you will get it. The sum of the terms of an AP equidistant from the beginning and the end is constant, and that constant is equal to the sum of the first term and the last term. Clear?
Yes.
Disha, absolutely clear. Goodman, Divansu,
Yes, sir.
and all of you,
Yeah.
Sagnik, Srijita, everything is very clear, dear students?
Yes, sir.
Okay, great. Then the next point is also very important. Okay. And you know how I bring all these points? By analyzing the questions what comes in different entrance examination, and by looking into all these problems,
Yes, sir.
you know, I generate this pattern. Yes, someone is raising some point, dear student. Okay, fine. The next point is also very important point. Okay. So the next point says that any term of an AP except the first term, any term of an AP except the first term is equal to the half the sum of terms which are equidistant from it. So, in simple terms, what it is saying is, if A1, A2, A3 up to AN are in AP, then we can say AP, the any term that AP, pth term you can say, is equal to the average of A of P minus K plus A of P plus K. Let's take an example, because if we take example, things become easier to understand. Let's take a very simple example of 1, 2, 3, 4, 5, 6, 7, 8, and so on. Suppose it goes in like this thing, but let's consider this is an arithmetic progression, dear students. Now let's take a number 5. That is my AP. Correct? No? Suppose let's consider this is equal to AP. Okay. So according to this one, what it says is that AP should be equal to A of P minus K plus A of P plus K divided by 2. Okay, let's understand. What is the value of P here, dear students? 5. AP is the fifth term, na? AP is the fifth term, correct or not?
Yes.
So what we can write A5, let's take K equal to 1, correct, na? And obviously P is equal to 5, we know.
Yeah.
Correct, no, dear students? P is equal to 5, that you already know. So what is the value of A5 we are going to get? A of 5 minus 1.
Yeah.
A of 5 minus 1 plus A of 5 plus 1. By the way, 5 minus 1, 5 plus 1, they all are, subscript here. In simple term, what it is telling is that A5 is equal to, it is nothing but A4 plus A6 by 2. Correct, no, dear students? Now, what is A6? A4 is the fourth term, that is 4, na? And what is A6? The sixth term, 6 by 2. That is equal to 10 by 2 is equal to 5, which is nothing but A5, na? AP. That you, correct? Clear or not clear?
Yes.
In that way, you can take any value of K, which is in between 0 to n minus r in generic sense. But in context to our discussion, it should be, that, we can take any value in the range of that, that K. Correct, no?
Yes.
You can find the value of A5 is equal to A of 5 minus 2 plus A of 5 plus 2 by 2. Correct or not? What we get it here? It is the average of 4 and 6. Correct, not dear students? That 5 is the average of 4 and 6. Similarly, we can say that 5 is the average of 3 and 7. That's it. That's what it is telling in simple term. That also you can say it is nothing but the average of 2 and 8. Correct or not, dear students?
Yes.
That's what it is actually saying. Clear, no? Okay, great. Now the next point, sorry. The next point what we are going to discuss is that if there are two APs, suppose A1, A2, A3, and is one AP, and B1, B2, B3, dot, 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 it is another AP. Then we can conclude few things. The first one is that we can say that A1 plus B1, A2 plus B2, A3 plus B3, A4 plus B4, all these things are in AP. Okay? And they're minus also. Got it, no, dear students? Let me place the note properly. So what it says is that if A1, A2, A3 up to AN and B1, B2, B3 up to BN are two APs, then A1 plus minus B1, A2 plus minus B2, A3 plus minus B3, all these things are in AP. And also, two more conclusion we can take is that A1 into B1, A2 into B2, A3 into B3, they are not in AP.
I'm not in.
They are not in AP. That's what it is mentioning. Okay? They are not in AP. And similarly, A1 by B1, A2 by B2, A3 by B3, they are also not in AP. Okay? Clear, no?
Yes.
Okay. The next point is also a very important point, and that is the last point as long as our discussion in arithmetic progression is concerned. And that I'm going to discuss in the next page. Or I can discuss here itself, because let me continue in this page only. Okay. So dear students, what we are going to discuss now is that if we need to find the number of identical terms of two distinct APs, suppose two APs has been given to you, correct, no? And you need to find number of identical terms. Possible, no? Let me give you an example so that it will be understood. Okay, suppose we have two APs. That first AP. Let me use a different color so that it can very clearly visible to you. Suppose the first AP is something like this: 1, 2, 3, 4, 5, 6, 7, 8, and it continues. And the second AP is something like this: 2, 4, 6, 8, 10, 12, 14, and so on. Correct, no, dear students?
Yes.
These two are distinct APs. Now, what is the discussion we are doing here now, dear students? The discussion we are doing is that we need to find the number of identical terms in these two APs. Okay? That means if you see, okay, that what are the terms are identical. Okay? That means, you see that term 2 is there in both the APs. 4 is there in both the APs. 6 is there in both the APs. 8 is there in both the APs. But you need to find how many such terms are there in this APs which are identical. Correct? No?
Yes.
And for the sake of completeness, we need to know that, that let's find that, it actually ends with 100. Correct, no, dear students? And here it ends with 100 as well, for example. So what we are going to do is that it is sometime you will find that question is challenging, okay? Because to here the APs looks like very easy, okay, very simple APs, but sometime you will get with some different common difference, and first term is something different, and you need to find out. But here is the steps. I repeat, dear students, if you do not follow these steps, then also you will be able to find the solution using your existing mathematical knowledge. But it will take little longer time than if you follow the steps. The first step is that let P be the number of identical terms in these two APs. So how many number of identical terms? Let's P be the number of identical terms. So now step 2 is that observe the first few terms of both the APs to get first 3 terms common in both the APs. Correct, na? For example, 2, 4, 6. Correct, na?
Yeah.
These 3 terms are an AP called AP containing identical terms. Correct or not?
Yes.
That is the step 2. Then step 3 is that find the pth term of this AP containing identical terms. So what we are finding? We are finding a AP containing identical terms, no, dear students?
Yeah.
Okay. So, and in that AP, let's find pth term, and let's say it is TP of this pth term of this pth term of this AP containing the identical terms. Now find the smaller of the last term of the 2 given APs. Okay, in the 2 given APs, let's find the smaller. In this case, in this example, okay, it is 100. Let us name this smaller term as such Q. Correct? Huh? So now what we need to find? We need to solve the inequality TP is less than equal to Q in the last step. Find the largest possible integral value of P satisfying this inequality, and the value of the P is the answer. Let me help you with this example. So what will be our identical AP containing identical terms? Let me use a different color. So AP containing identical terms. Are you getting my point, dear students? AP containing identical terms is 2, 4, 6, 8 in that way. Correct or not?
Yeah.
So in this term, we are assuming that pth term. In this AP, what is the pth term? Pth term is nothing but we define as TP, that is equal to A plus, that means 2 plus P minus 1 into D. D is what? 2. 4 minus 2, correct or not? Common difference.
Yes.
What we are getting? 2P, 2P, correct, na?
Yeah.
2 plus 2P minus 2 is 2P. Now what is Q? Next term is that. What is the value of Q, dear students?
100.
Very good. 100. Because Q is the smaller of the last term of the given APs. So Q is equal to 100. So what we need to do? We need to solve the inequality. Let me use a different color. We need to solve the inequality that TP is less than equal to Q, na? According to the 5th step.
Yeah.
TP is less than equal to Q. That implies what? What is TP? Pth term is 2P, correct, na?
Yeah.
2P is less than equal to 100. That implies P is less than equal to 50. Correct, no? That is a solution of the inequality, correct?
Yes.
And the largest possible integral value of P, which is that? 50. Okay, so 50 is the answer. That means there are 50 identical terms. Obviously, that also you can observe, no? All the even numbers in the second, all the even numbers, correct, no?
Yes.
So second AP contains actually 50 terms. If you see 2, 4, 6 up to 100, correct, no? All the even numbers, and that even numbers is part of the first AP, no? Because the first AP contains both even and odd numbers, correct or not?
Yes.
So from this, what we can say is that p is less than equal to 50. So from here, what we can conclude, the largest possible integral value of p, largest possible integral value of p is equal to 50. Correct, no, dear students? So 50 is the answer. But if you do not follow these steps, let me repeat, dear students, you'll be able to solve it. It is not that you can't, but it will take longer time. And I repeat, as time goes by, I'll always give you this step-by-step methodology, which will help you to solve problems. Anyone has any difficulty in understanding this, please feel free to me. Dear Gurman, understood?
Yes, sir.
Disha, Divanshu, Sagnik,
Yes.
Srijita, Mohit,
Yes, sir.
absolutely clear? No doubt?
No, sir.
Great. Now, what I would like to do is that I would like to discuss, this is all about the arithmetic progression, what I have, as long as the fundamentals, concepts are concerned. So now, as I said that, the two DPPs I gave yesterday, so if you have any question out of these DPPs, please do let me know so that I can work on this. Anyone has any doubt in these DPPs? If it is not, if you do not, because the DPP was not that difficult, by the way, but that doesn't mean that you may not have, doubt. You may have doubt, no problem at all, because you are learning. Definitely, you have doubt. If you have doubt, it is nothing wrong at all. At all, it is not wrong. Now, if there is no doubt in the DPPs, we will proceed to solve some questions together.
Yes, sir.
Anyone has any doubt?
No, sir. I
No?
don't.
Okay, great. All right. So now let me proceed towards solving some questions together. Correct or not, dear students?
Yes.
So the question what I'm going to give is a very representative question. Leveraging, you need to apply the concept of logarithm as well, dear students. All of you got the question, dear students?
Yes.
Go ahead. Is the question clear to all of you, dear students?
Yes.
The question here is that log 2 to the base 3, log of 2 power x minus 5 base 3, and log 2 power x minus 7 by 2 base 3 are in AP. If these three terms are in AP, then find the value of x. Let me solve it, and you also solve along with me, dear students. Okay. So if you recall from the concept of arithmetic mean, we can say that this term, that is log 2 to the power x minus 5 base 3, should be the average of log 2 to the base 3 and log 2 power x minus 7 by 2 base 3. Correct or not?
Yes.
Or the other way what we can say is that, so this statement tells us to conclude that log 2 to the base 3 plus log 2 to the power x minus 7 by 2 base 3, that is equal to 2 into log base 3 2 to the power and 2 to the power x minus 5, means 2 into log 2 to the power x minus 5 base 3. Correct or not, dear students? Correct? Okay. So, in the left hand side, what you can conclude, dear students, is that, we can say that log of m plus log of n with the same base, that means log of m into n with that same base. That means, it means log of 2 into 2 to the power x minus 7 by 2 with base 3, that should be equal to, we can write log base 3 2 to the power x minus 5 power 2. Correct or not, dear students? Because we know m log n is equal to log n to the power m. That 2 becomes power, na? That 2 goes to the power. Correct or not? Dear students, all of you got it?
Yes.
Now, as there is a log base 3, we can cancel this. We can actually come out of this log, by the way. Correct? So, in very, generic way, we can say 2 to the power x minus 7 by 2 is equal to 2 to the power x minus 5 whole square. Correct? No? As I suggested at the beginning, dear students, you also solve along with me, because I am solving slowly so that you get the point, everything. Correct or not? This implies, because if you just observe, you'll not able to make much sense out of it. So then what we get? We get 2 into 2 to the power x minus 2 into 7 by 2, that is 7. Correct, not dear students? That is equal to 2 to the power x whole square. Correct or not? 2 to the power x into 2 to the power x whole square. Correct?
Yeah.
2 to the power x whole square minus 2 into 2 to the power x into 5 plus 5 whole square. Correct or not? Clear or not clear?
Yes.
So from here what we get, dear students? 2 into 2 to the power x minus 7, that is equal to 2 to the power x power 2 minus 10 into 2 to the power x plus 25. Correct or not? So from here what we can write is that 2 to the power x power 2 minus 12 into 2 to the power x, correct or not, dear students? Plus 32 is equal to 0. Correct or not? Absolutely clear, dear students. Now, what is our task? Our task is to find the value of x. But it looks like a quadratic equation in 2 to the power x. So the best thing is that, let's assume that 2 to the power x equal to, let's say we assume 2 to the power x equal to a. So what we get? We'll get a square minus 12 into a plus 32 is equal to 0. Correct or not, dear students? Since, here let 2 to the power x equal to a. So from here what we get, dear students? We get, it is a simple middle term factorization, a minus 8 into a plus 4, a minus 4, a minus 4 is equal to 0. Correct or not?
Yeah.
So from here what we get? From here we get a is equal to 8 or a is equal to 4. When you get a is equal to 8, that means what? 2 to the power x equal to 8.
Yeah.
That means 2 to the power x equal to 2 to the power 3. That implies x equal to 3. Correct, no, dear students? Clear or not clear?
Yes.
Okay. Now, if we get 2 to the power x equal to 4, so this implies what? 2 to the power x equal to 2 to the power 2. That implies x equal to 2. Now there is an interesting point. Okay. So what you will say? You will see that, okay, both the answers 2 and 3 are correct, apparently, right, no, dear students? But let me tell you, not both are correct. One is wrong. One is not acceptable solution.
The x equal to 2 is not.
Why not?
Then the log 2 to the power x minus 5 becomes negative.
And log of negative is not defined. Very correct answer. Appreciate Mohor. So, all of you, I hope all of you understood, no, dear students, that if we apply that x equal to 2, what will happen? Then we'll get that 2 to the power x minus 5 is equal to 2 to the power 2 minus 5. That is equal to minus 1. That implies log of 2 to the power x minus 5 is not defined, which is not the case, na, dear students. All of you please remember, we touch base on logarithm, the log of negative number, it is of no meaning. Okay, when you'll discuss in functions, you'll find there is something called domain. Okay, so log of a negative number doesn't make any sense. Hence, x equal to 2 is not an acceptable solution, and the only acceptable solution is x equal to 3. Correct, no, dear students? All of you got it, dear students? Because that is a very classical question, very important question. And with this question, we understood few things. One is that how to apply the concept of arithmetic progression, followed by we see that how we convert an equation to a by means of transformation to a quadratic equation. Then we solve that quadratic equation. Then after that solving, that we see that no, not all values are actually acceptable because it violates the definition of the domain of the logarithm. Correct, not dear students? Okay. Now, let us solve another question. Okay. The next question, what I'm going to give you, dear students, is not that difficult a question. And I appreciate if all of you can start solving with it. Okay. If someone is not able to understand this question, please feel free to me. Okay. Because that is very important, that if you do not understand, you should always, ask that what is meant by this question. Is the question clear, dear students?
Yes.
Devansu, is the question clear?
Yes, sir.
Okay. So the question here is that find the sum of all the multiples of 7 between 500 and 1000. Find the sum of all the multiples of 7 between 500 and 1000. Can someone please let me know how you are going to approach this question?
Sir, we take A as 544
Very good.
and D as 7.
I appreciate. So if you take A is equal to 504 and
Yeah.
D is equal to 7, I appreciate. Very good. Then
Then we use A plus n minus 1 D, and we find the number of terms. Then before that, we find the last term for the like before 1000. which is divided by 7, which is divisible
And
by 7.
that number could be what?
Just 1 second.
So I think it's 994.
Fantastic. Appreciate, Gurman. Yes,
Okay.
it is absolutely correct. Both of you are going very well. Correct.
Yes, so then 994 is equal to a plus
N minus 1 into D, and from there you find the value of n. Correct, no? Then after that,
Then after that we use n by 2 a plus l.
fantastic. All of you understood. Okay. So, I can explain. Very good. Appreciate the answer. So, what is the question? Is find all the multiple of 7 between 500 and 1000. So, between 500 and 1000, what is the first term which is multiple of 7? That is 504, na? The first number will be 504, which is a multiple of 7, and immediately after 500. After that, next term will be what? 504 plus 7, correct or not? 511, correct or not? And then next term will be what? 511 plus 7, that is 518, correct or not? And in that way, it will continue and continue till what? Till the number which is divisible by 7 before 1000. And as Gurman correctly answered, it is 994. So, in simple terms, from this word problem, we constructed a AP. Correct?
Yes.
And all you need to find is that we need to find the sum of all these terms of an AP. So, what is that sum? Suppose let's assume that sum is equal to S. Correct, no? So what is that? That means S is equal to 504 plus 511 plus 518, and in that way it will continue till 994. So how to do this thing? So there is a formula for that. And the formula is that, as Devanshu said correctly, it is n by 2 into A plus L. What is the A? A is the first term, that is 504. And A, what is L? L is the last term, that is 994. So all we need to find, dear students, is the value of n. Done. Then our problem is solved. Now, how to find the value of n? So we know the last term is 994. Correct, na? N means what? N means is the number of terms.
Yes.
So then what we can do, dear students, if I use a different color, these 994, these 994, I can write something like this. That 994, which is the last term, and let's assume it is the nth term, it should be A, that is 504, plus, by the way, Devanshu, Guruman and others who already got it, can you please find the value and let me know the exact answer, the sum of all the multiples. I am explaining it slowly. Meanwhile, you can get the answer, you can let me know.
So,
So I got the answer as 53179.
yes, even I got that.
Okay, great.
Yes, sir.
So n minus 1 into D, and D, as you see, it is actually, 7. Dear Sagnik and Disha, you keep quiet. You also got it?
Yes, sir.
Sagnik, Srijita. So we get the value n equal to
Yes, sir.
Okay, great. N equal to 71. Now that value of n, which is equal to 71, if we apply here, so what value you will get it here, dear students? Whatever you'll get. So I'm just writing the expression. That is 71 by 2 into 504 plus 994. And as all of you said, the answer is 53179. That is equal to 53179. Let me tell you, dear students, apparently the statement what I'm going to make, it may sound that, okay, you'll not feel very comfortable, but it is a very practical statement. There are a lot of problems in this sequences and series. Lot of problems. The statement what I'm going to make now is that it is also true to some extent for as long as your next 2 years is concerned. You need to make a lot of practice. And the best way to make a practice is that, go to the online platform www.KonarClasses.com and then start doing the practice test. The more you practice, the more it is actually beneficial. Okay. Now I'm going to give you the next question. Okay. And that will be the last question for today. And the question you are going to get shortly. Yes, dear students. I hope you got it.
Yes.
Just take a few minutes, a couple of minutes, dear students, to solve it. After that, I will, help you.
So are the terms 2, 5, and 8?
Okay. Appreciate very much. And but still I can say, so what is the question here is that find the terms. Okay.
There are two possibles.
Correct. You are in the right track. Yes, Mohit. Yep. It is 258 and 852. Correct, no?
Yes.
Yes,
Good
I
one.
got 258.
Yes. Okay, got it.
Yeah.
Okay, great. So let me solve it in case you are not getting it. Some of you are not getting it. So let me solve it for you, dear students. So let's the three terms, always if you recall from the theory that we will assume the three terms as it is mentioned, the three terms, no, dear students. So these three terms, what I'm going to make it is that it is, let the three terms be a minus d, a, and a plus d. I hope all of you got this thing. And according to the question, their sum is equal to 15, correct, no? Their sum is equal to 15. So from here, what we get? A minus d plus a plus d equal to 15.
Yes.
That is equal to a minus d plus a plus d equal to 15. So from here, d got cancelled and we get the value of a is equal to 5. Correct, no, dear students?
Yes.
So one thing to we are pakka sure is that, okay, we got the middle term. Done. And the third term exceed the second term by 11. What is the third term? Third term is, and the product of the first and third term, sorry. The product of the first and third term exceed the second term by 11. So the product of the, so let me use a different color so that later you can follow it properly. The product of the first and third term exceeds the second term by 11. That statement leads us to make this, equation that a minus d into a plus d, correct, na, dear students?
Yes.
A minus d into a plus d, that is equal to a plus 11. correct? So from here we apply the value of a, and you will get something like this. I'm not doing in details because that you should not be doing. So you will get something like that d square is equal to 9. All of you get it. If you do not get it, then you can let me know. So from here we get two possible values of d, that is one is plus 3 and the other one is minus 3. So now if we take the value of a is equal to 5 and d is equal to plus 3, correct now, dear students? So what are the three terms we are going to get? A minus d, that is 2, a is 5, and a plus d, that is 8. And if you take the value of a is equal to 5 and d is equal to minus 3, then what is the first term we are going to get? A minus d, that is 5 minus of minus 3, that is 5 plus 3, that is 8. Second term is a, it is 5. And the third term is a plus d, that is 5 minus 3 is equal to 2. Correct or not? So these are the two, possible answers. Correct?
Yes.
Okay, dear students. So now I would like to give you little more DPPs for today. Okay. And for that, I'm just going to stop sharing this screen and going to share another screen with you. That is our website. And you need to take a note of it, that what are the, DPPs you need to solve. Correct, not dear students? All of okay, let me first show all of you the website. Please confirm once you are able to view the website. Please confirm me.
Yes, sir, we can see.
Okay, great. So then click on login, and by this time you know better than me, I hope. Login, then go to the write online examination, then just write sequence. You did first two, na?
Yes.
Then for step 3, set 3, write test. So please work on this set 3. Correct?
Yes.
Then you go to set 4. Okay, each and every problem is important. Okay, you do one thing, set 3 and set 4. That's it. I thought of giving more, but let's do it. Set 3 and set 4. But if any one of you or some of you or all are able to complete both set 3 and set 4, please do let me know. I'll give you some more, extra assignments from the relevant book. Okay, that book what I have written. So that I'll send you the problems from that book as well. So, but as long as the DPP is concerned, you do 3 and 4, and the moment it is done, please do ping me over WhatsApp, and I'll give you some more assignments. Correct, my dear students?
Yes.
Okay, and before I conclude, what I can do is that you just give me just give me 2 minutes, please, so that I can give you a couple of questions, which you can work on it. I just want to give you four questions, dear students. So, and I will appreciate if you can solve these 4 questions and submit to me before we start our class tomorrow. Okay, you'll be able to get it shortly. Not 4, dear students, just 5. I hope you are able to view the screen now, dear students.
Yes.
So this is the first question. This is the second question. This is the third question. This is the fourth question, dear student. This is the fifth question. Okay. So tomorrow we will do some more practice on arithmetic progression, and then we'll start, touch base on just start the beginning of geometric progression. So with this, I would like to conclude the class for today. And please do contact me over WhatsApp. Can we start our class tomorrow onwards 8 o'clock? Possible? If you can communicate to me over WhatsApp. At least I said 6:30. That may be too early for some of you. But see if you can start at 8 o'clock and do contact me over WhatsApp. I'm just proposing it, and then we will discuss in WhatsApp in more details. Okay, dear students. Okay, thank you very much. Take care.